All right, so we're going to talk about text to video. There is a new open source model. I'm calling it Model Scope. There's a couple other names for it out there. Text to video, I think, is sort of what everyone's going to talk about this year, but we'll sort of see where it actually goes. This is a sample from a piece I'm making right now. You'll see coherence is okay, but it definitely still has a little bit of a flickery, jittery vibe. So, as you work on this, don't expect perfection, but it will be pretty interesting. So I'll talk about how to fine-tune your model, and then I'll also talk about how to do inference. So I've got a little collab notebook set up for everybody to sort of experiment with that. So with that, let's get started. All right, so I have our collab notebook here. If you downloaded this from my Patreon account a couple days ago, highly recommend you download it again. I'll drop the link to this in the video notes because I've made some updates since then, so it's probably important to do that. So in order to get this started, I'll just go ahead and hit connect here, and then we'll get started. But the best way to fine-tune your model is to have a bunch of videos. So again, think about just like any other sort of training sequence. You're going to want a lot of video. I did the training or the video that I was showing earlier, I did on about 25 videos. Obviously, the more video you get, the better it's going to be. And we'll look at how to auto-caption those so that you don't have to create your own captioning system. But the other thing to note about those videos is they should be individual clips, right? So there shouldn't be cuts in the middle of your sequences, that sort of thing. It's very likely going to interfere with the training of your image. So individual videos clipped, I recommend putting them in Drive because it's just going to be faster to upload to Drive than it is to directly upload to Colab. So let's go ahead and get started with this Colab notebook. So obviously, as I said, we're going to drop things in Drive, so we'll go ahead and connect to our Drive account. I just made a folder in Google Drive, called it text to image videos or text to video videos, and just uploaded them there. It doesn't really matter. The training for this is going to be quite small, so we can keep it pretty small in terms of video sizes. I believe what we're going to look at for this is 354 by 256, something like that. So it's quite small, and you'll see our outputs are a little blurry because of that. But, so you don't need to find 4K video because it's not going to do much for this training session. Once we're connected to Colab, we're going to run this cell for the first time. So the first time we run this, it's going to install the text-to-video fine-tuning repo, and then it's also going to install some requirements. One thing I'll note is some people said to install Xformers. Supposedly makes things a little bit faster. In my experience, it did not make anything faster. And also, it forced you to push to PyTorch 2, and PyTorch 2 has a bunch of issues with it right now, including out-of-memory errors a lot more frequently. So I've actually turned Xformers off. Your mileage may vary. Let's go ahead and run this. In my case, I already have the existing directory, so it's already existed. So all it's going to do is install all of the requirements necessary to run this on Colab. Other thing I should have mentioned, I know I mentioned this on my Patreon, this does require an A100, so make sure that your runtime is set to premium. I believe high RAM is also really important, especially for the blip captioning. We'll look at that in just a second. So unfortunately, this does require a Colab Pro Plus account. If you have a local GPU and you have maybe 24 gigabytes or more on a card, you could probably run this locally. I would say if it's anything video, you generally want to be running it on a pretty beefy card because it needs to look at a bunch of visual video sequences, which just requires a lot more memory. So then this next thing we're going to do is we're going to install the actual the database. So the repo we're using is actually based on this thing called Damo VLab. This is the text to video model that was released maybe 2 weeks ago, and is an open source model. So running this command will actually install it. I've already got it installed, so I'm actually going to skip over this because I don't know if it's going to reinstall. And this is quite a large model. I want to say it's something like 10 gigabytes worth of files. So this will take a while. So you should run this. I am going to skip it just because I already have the files necessary. This will take a little bit of time. It took me I think 10 or 15 minutes to download all these. Next, we want to actually create captions for our videos, right? So again, we want text to video, which means we need text captions. You could probably write a caption for every one of your videos by yourself. The person who made this library also made this repo called Video Blip 2, so it uses the Blip tool, which I think is from Salesforce, I want to say. And what it does is actually kind of interesting. It looks at different frames of your video and then combines them into a single sort of text prompt. we'll look at this in just a second in order to sort of see how the prompting actually works. So we'll go ahead and run this. Again, I already have it installed, so it should be a little bit faster for me. But in case, anyway, it's just going to install the code necessary here. And sure enough, that's done. Okay, so now we need to talk about pre-processing our videos. So that just means we need to create our text prompts in order to run this. So over here, you'll see in Drive, my Drive, I've got a folder called Blip2 Videos. And inside of here, you'll see I've got a couple different videos, although that is not the one I wanted. I want this one, which is Secret Flowers. So in here, you'll see there are just a series of different videos. They're all MP4s. They're all 1080, so I think they're like 1440 by 1080, which is fine. I get the sense that cropping might not matter too much. I think it might auto crop. What I would say, though, is if you have black bars above or below, you probably do want to crop those out so that those don't get introduced into your training video. Just like with any training set, make your training data as clean as possible. It's probably the best way to go forward. Okay, so now we're going to actually process our videos. So that is just going to mean going into this repo, which is the Video Blip 2 preprocessor, and then running a command. So I'm actually not going to run the entire argument here. There are different arguments. If you want to take a look at them, you can. What I've generally found is there's maybe 2 or 3 things you want to worry about here. So first off, in this command, the first thing we want to do is we want to point this to our video directory. So this should point to this folder here. So you just copy, go ahead, hit copy path, and then paste that in. Next, you want to give your config a name and a save name. I don't know the exact difference between these two. I think this is like, you know, what the JSON file internals name is, and this is what the actual name of the JSON file is. So, you know, keep it pretty simple, and just as long as you know what you're looking for. Next is prompt amount. This is how many prompts it's going to create per video. So the way to think about this is, let's say you have a very long tracking shot, and I don't know, it tracks from like a car scene to a architecture scene to someone walking. If that's all one sequence, then really what you don't want to do is just create one prompt for it, right? Because if it only captures the architecture prompt, it's going to kind of add distortion into it. It might say like, hey, you know, everything you see here is only architecture, and that means you've got people and cars and other things, and it's going to get kind of confused. So it actually generates a number of prompts per sequence. What I would say is the shorter your video clips are, the lower this number needs to be, because of the likelihood of these being the same prompt when it gets regenerated is pretty high. So in my case, I had very short clips. They're like 4 seconds each. This is probably actually too high for what I was doing. I probably could bring this down to like 4 or 5 and it'd be fine. It's just going to create a couple different like slightly random or slightly differentiated prompts for your video, which will then help the model sort of train, right? It sort of says like, hey, if there's 20 videos in here, but there's slightly different images in each one of them, the model will learn sort of that different text prompt sort of argument in there. There are other arguments, but I sort of think these are the most important ones. So prompt amount is probably the one you're going to want to change based on the video you upload. So let's go ahead and run this. This takes a little while to run because it sort of has to go and like download a bunch of files. It's a little bit of a slow process. So the first time you run it, it might be very slow. You'll see it's downloading all these configurations. It's going to download some models. It's going to take a little bit of time to download that. You'll see some of these. Yeah, so there's like a 10 gigabyte file here. So this is very slow. So while this runs, let's talk a little bit about what's going to happen here. So when we're done, what we'll get, or what we should get, is a JSON file. And that JSON file should include every video and then a series of captions correlated to that video. It'll also tell us what frame count that starts at, other things. The important thing to remember is that this needs to go to a folder, so don't point it toward a single video. There is a way to do single videos. I'm not really going to cover that in here because honestly it's kind of overkill. Like, I don't know that you should really be doing that for this technique because we're training a whole model on our images, so it's kind of a tricky little scenario there. I'd probably recommend that you do this on 5, 10, 20 video clips, as you're more likely to get better results doing that. I'm actually going to pause the video, and then when this is finished, we'll come back and take a look at it, because I think there's going to be a decent amount of downloading going on here. Oh, no. Okay, actually, maybe I take that back. We're at download shards 2 of 2. So there's some sort of sharding system here where you don't download the entire model all at once. It downloads into little pieces, and then once you've downloaded the pieces, the shards, then it like sort of combines them back together. So I think maybe another minute here before this finishes running. Actually, I'll kind of go ahead and just sort of show you what this looks like. So inside of your text to video fine tuning folder in Drive, you will then see a folder called Video Blip 2 Preprocessor. You'll open that, and then in there you'll see a folder called Train Data. If you open that, you'll see I've run this a couple times. So I've got the secrets.json file, which is what I'm really looking for here. So we'll click and open this, and you'll see over here we have the name, which is what we defined, and then a bunch of video paths, how many frames are in that, and then at each frame index a different text prompt. And you'll see here, for this first one especially, a lot of the text prompts are the same. And this is kind of a good sign that maybe you've got too many text prompts. Maybe this is where you would want to reduce it to, say, 4 or 5 or 6 instead of 8. It probably won't affect your training too much. It doesn't seem as clean from my perspective. So here again, this video has a number of very common, very similar prompts. One thing I'll note is that maybe if what you're trying to capture is not just content, like you're trying to capture, like, say, a tracking shot or a pushed-in shot or a close-up, you might want to define that here, because I don't think Blip knows a lot about video, right? It's sort of processing this on individual clips or individual frames. So stuff like a tracking shot left to right or a person walking from left to right, you might want to actually update your prompt here, and you can just click in here and just add additional features or add additional text. If something you want to also be able to process on the output is moving from left to right, then that's something you probably want to include here. Blip makes it easier because it sort of does a lot of the captioning for us, but there's certain things it isn't good at. It's not good at tracking motion or understanding what's happening in the scene in terms of motion. It's only going to tell you content that's in the scene. So just be aware of that, and that might be something you want to update. I haven't played with that stuff yet, but it's probably worth checking out. So you'll see that over here it is actually processing. It's sharing our video. So what it's going to do when it's done is just do exactly what we saw, which is produce that JSON file. So I'm going to go ahead and hit stop here, so we can go ahead and move ahead. I'll throw an error or whatever. I don't think that'll break my file. Let me just double check. There might just be a shorter number of video clips in here, but that's fine. Cool. Okay. So at this point, we now have our clips, we now have our text prompts, and now we want to go and actually train them. So to do the training, we're actually going to update our file paths here. So what I'm going to point out to you is stuff that you might want to edit, although in my case, some of these are actually still correct based on what I was doing. So the important things to look at here are the pre-trained model path. So in 9 times out of 10 cases, I think what you're going to want to do is actually point this to the download that you got from the step we skipped, or the step I skipped, which is, what is it? It's this one. So this is where you download the text to video model files. So in order to do that, if you follow these steps exactly as is, where that is going to end up is it's going to be this folder here. So you'll copy this path, and this is probably already set if you download my Colab notebook, but you're just going to set this path. So it should be text to video ms17b. This is what we're going to pick up training from, right? So this is our pre-trained model, and we're going to fine tune or transfer learn from this file. Next is we want to assess our training data. So in this case, this path needs to go to our JSON file. So if you gave your JSON file a different name, you'll want to come over here and maybe grab a different path, and you'll want to paste that in. Next, n sample frames. So this is how many frames are we going to sample within our video. You want to make this kind of as high as possible. The downside is that the higher you make this, the more VRAM you're going to use. So in this case, if you have like a whole, like, I don't know, like a minute-long clip, then the number of frames for a minute-long clip at 24 seconds would be 1440. This would likely cause an out-of-memory error and crash your system. So what I have found works on an A100 is something like 40 to 60. So you could put in 60. By default, this value is 2, and that is way too short. This is how many frames it's going to try to look at to try to sort of create a coherent video animation. So you kind of want to make this as high as you can. So what I would say is maybe 48. That's 2 seconds, which would hopefully give you a fair amount of sort of length. Shuffle frames, I don't really want to use that, I think, because we want coherent video, so we don't want to shuffle those frames as we're looking at them. Like I said, width and height is 348 by 256. I have not played with making this larger. I can imagine that would create out-of-memory issues, but also I think the pre-trained model is either trained at 256 or at 384 by 256. So therefore you can't, I don't think you really want to make it bigger. I mean, I haven't really tried it. It's fine as is. Maybe someone will play with that in the future. But for the moment, like, that's kind of what I would leave it at just to be safe. Sample frame rate. So if you're uploading video that is 60 frames per second, you should probably set 60 as your frame rate. If you have mixed frame rate, I might set like an average, like maybe 24 or 30. Again, I think the idea here is that this creates some coherence. It's able to understand how many frames per second it's trying to generate, and then is able to process that. Last one I think was video data key. This one took me a second to figure out. Just leave it at video path. Don't play with that. If you do anything more with that, you're going to run into errors. I'm trying to think if there's anything else here. We can skip a lot of the validation data because it's going to create auto process some validation for us, which means it's going to spit out samples that we can then look at and sort of see how they go. There was a note in the repo around change in learning rate. I haven't played with that too much, but that's up to you if you want to do that. Obviously, a little bit lower would mean it trains a little bit slower. A little bit higher would mean it trains a little bit faster. This being the default seemed pretty good for me. I might experiment in the future with lowering this or making this higher. We'll sort of see. Batch size I kept at 1. Again, this is a thing where you could probably crank it up a little bit, like maybe to 2 or to 4. But this plus the combination of n sample frames is going to change your VRAM usage. So you might kind of want to need to play with that. This is how long it trains for. Most times the model will stop before it hits here, but I guess on an A100 it probably would actually run. So I have found that about 50,000 steps takes about 12 hours to run. I've also found that is way too high. And we'll talk about this in a second when we look at some of the checkpoints I've generated in the past. In my experience, something like 2,500 to 10,000 is plenty. I'll talk about why that is or what that means or what the differences are, but you can kind of take a look at that. So set this max value. If you leave it at 50,000, it'll just keep training up until it hits that point. I would say you could probably set it to 2,500, and that would really... I can't imagine a world... I mean, maybe if you have a ton of video and you want to completely change the model, then maybe it would matter, but in this case, I think 2,500 is fine. Checkpoint steps, I recommend saying that 2,500 because, as I mentioned, I think the first checkpoint that I think is really worth looking at is the 2,500 step checkpoint. There's a good balance of it still being the existing model and learning a little bit of your new stuff. So take a look at that. And then validation steps is how often you get a sample video put out. This was by default set to 100, which was like you got a lot of videos. They're pretty short, but I still find that like you don't need that many. So 250 seems right. I've set trainable models to the attentions layer. There's a note in the repo if you want to go look at it around which ones work best for VRAM usage. For an A100, attentions is fine. This is supposedly the highest quality, but it's also the most GPU intensive. If you are trying to get this to work on a 24 gigabyte card, you might want to look at that note. I think there were some other layers you could name. These are the layers that are actually trained. So in this case, it's going to train all of the attention layers, I believe, whereas you could set just a couple of the various attention layers to be trained. Seed, I don't think that really matters. We are going to do a mixed precision model, which will give us maybe lower quality results, but it'll be able to run faster and that sort of thing. Last, I mentioned that I turned Xformers off. If you want to turn that on, you just want to make sure you turn this on and set it to true. And install Xformers. If it doesn't see it, it's probably going to throw an error. Okay, now that we've set all of our settings here, I'm actually just going to set this back to secrets. So that's what I've been working with. We're going to hit play on this file just to save this file out. So you save it out as a YAML file just so you can train off of it. So we'll hit that. And now we are ready to train. So this saved out as a file called myconfig_HQ. This is the high quality version, which of course is probably better for us as artists. So that's what I saved with. Next, to run this command, you're just going to make sure you're cd into that folder and then actually just run the train command with this config file passed in. So go ahead and do that. Now, a couple notes. This does take a little bit of time to get kicked off, but actually doesn't take too long. You'll see I've got a couple like TensorFlow errors. I think these are just like process. I don't know. We're not even really using TensorFlow here, but it's still a little bit of an issue. So these are all warnings that I've seen. None of them have affected the training as far as I can tell. One thing to note is that these do spit out video using this validation data. So you'll see here, it's going to generate 16 frames, a total of 16 frames. And I believe it uses some like 8 frames per second. So the videos will feel a little like slow for the outputs. They'll feel a little choppy. I'll show you how to change that for inference. I didn't actually see if there was a way to edit that in this key. Maybe there is, but for now this is probably fine. And we'll actually use these as our defaults for when we actually start doing inference. So we're still going here. All right, so while this runs, what I can do is I can just show you what the outputs look like as we go through here. So I've obviously run this a couple times already. You'll come back over here and you'll go to text to video fine tuning. You'll go to outputs, and all of your outputs will be dated. So they will come through with just like a date on them, and you can open them. And in there, you'll either see samples and configs. This is one that actually has not, I must have stopped the training or something, or I screwed up something. There should also be a folder called checkpoints. Apparently I screwed up a couple of these. There we go. So you'll see each of these folders has a checkpoint value in it. And these are what we're going to use for inference. So you can see the samples in here. There are a lot of samples. They all come with a step number, meaning that's how long it's been training for. And then it pulls a random prompt from your JSON file to actually generate, to see if it actually did a good job. So you could download one of these. And you could go ahead and open it. One other note about opening these is they don't open in QuickTime. They'll look corrupted. They'll look like this, and you can't play that. So you have to open them in a program called VLC. So if you have never used VLC, just go ahead and Google it and download it, and you'll open it. And when you open it, you'll see here's a little video. Now the frame rate on that was very short. It's a very short video. It's just enough to sort of tell you like, hey, does this look like what it should, right? So like let me grab a very early one here. Let me see if there's something in the hundreds. 250. Let's grab a 250. So one thing you'll note with these videos, let me pause this real quick, is if you've looked at the other text-to-video, the model scope versions, a lot of them come with these watermarks. That's because they train on a bunch of Shutterstock video, and therefore all the watermarks are kept. You'll notice that as we train our model more and more with our custom data, the Shutterstock watermark does go away, and we'll also use some prompting later to try to remove some of that. But just be aware that your early steps might have this watermark on it. That's okay. It will be trained out as we go through. But you can kind of see like this one it actually looks pretty good even at 250. Maybe the model already sort of knew what some of these things looked like, but it does have the watermark in it. But you will also see like it's kind of this flickery thing. That is pretty common with this model. It's not the most coherent. It sort of is what it is. So you'll see here now we are training. So usually what it does is these 50 steps. This is actually, I believe, the first video, first output video sample being created. And then you'll see it is training. And it kind of gives you a length of time. So it says it'll take about 6 hours. That's about right. I said 50,000 would take 12, and this looks like it's going to take about 6.5. So again, A100s are pretty fast. If you were to do this on a T4, it would probably be this times 4. And you can't even run it on a T4 because the VRAM is way too low. So you do need to use an A100 on this. So as you go through these steps, it will generate a new video for every step, that step increment. And then it will, basically at your checkpoint value, which I set it to 2500, here, checkpointing steps, it'll save out your actual model file. So if you don't make it to 2500 steps, you will not get a model file. So that's kind of important to know, is if you get disconnected or like if you run out of money or whatever through your credit system, you will not get a model file until you hit this value. So if you're kind of concerned about that, you might want to set this lower and set it to 1,000. You might also want to set it to 1,000 just to sort of see different steps and play with them. The only thing to know is that these files are quite large. I think this is about like 5 to 10 gigabytes of files per checkpoint. So if you have a small Google Drive, which I do on this account actually, you have to kind of make sure you're going in and clearing stuff out because it can overfill your Drive account quite quickly. So as I mentioned, I think worth checking out the 2500 step, the 5000 step, maybe the 7500, the 10,000 step. In my experience, the longer this trains, the less likely there is to be actual movement in your video file. I have sort of noticed if I have trained it for 50,000 steps, if I open that 50,000 step checkpoint file, I actually tend to find the prompts are pretty static. They don't move a lot, and I'm not sure why that is. I might need to go and tweak some settings, maybe tweak a learning rate. But in general, I've found like the earlier checkpoints do actually work better, especially if you're looking to tweak your prompt. So the way this is working is like it's going to sort of train on the prompts we give it, meaning if you give it that prompt again, you should pretty much see your video back out. And I don't know, maybe there's a reason you want to do that. There's a reason I did it. But the other reason is that's kind of a waste of your value, right? Again, like you could always just replay your video or re-edit your video and get back what you wanted. In this case, what you might want to do is actually say like, hey, instead of a red flower, I want a blue flower. Or instead of some stuff I was doing, like instead of a flower, I want a mushroom. And it will kind of give you a mushroom that looks like the flower you fed it, right? So that's sort of the challenge of this. And that's the challenge of training is if you overtrain, it will only learn your videos, right? It'll be overfit to your video and you won't be able to really use prompts to sort of change it. And I will say this model, I think it kind of does overfit a little bit. Maybe I could play with some training changes, like changing the learning rate or something else. But I generally do find it does tend to overfit a little bit. And that's where I've introduced some other tools in the inference steps to sort of maybe overcome some of that. So as you train, you will see like, it's sort of going to go through steps. At some point, it's going to hit some step here and say, we're going to output a video. Actually, maybe it already did that. Yeah, it did. So when it hits step 250 here, it then goes through and processes our video again. And if I come back to my latest folder here, I should see in samples, I should see a video for 1 and a video for 250. And if I download 250 and open this in VLC, I do get a rather interesting looking video. That's kind of cool. Yeah, so that's an interesting looking video. It is not, you see a little bit of the Shutterstock watermark there, but it clearly doesn't know this data very well. I think I know why that other video was. I'll come back to that in a second. So obviously you train it as long as you can. I think it's worth training it at least to 25,000 steps, 250, was it 25,000? I think it's 25,000. Training it that far, just so you've got all of the steps and then you can go through them and use Inference to sort of try them out and test them. I'm going to go ahead and stop this, and I'm just going to talk a little bit more of that. Like, let's say you had to turn your machine off in the middle of the steps, and you want to go back and keep training from that step. There is some resuming functions. I haven't found them a way to get them to work particularly well. What I would probably actually, so there's this resume from checkpoint. What I would probably actually do is just feed your latest model. So let's say I stopped at 15,000, wanted to go to 25. I would just copy this path, and then I would put this in as the pre-trained model path. What that is going to do is it's going to pick up from your previous training and continue training on top of that. The difference is you won't start at 15,000 for your next step. It'll be at 0. So you have to remember to do a little bit of math to like be like, oh, I only need to go to 10,000, and then I just like that's 25,000. I've got the 2 models in two different folders, that sort of thing. This works for me. Maybe there's some sort of like learning curve set up in the learning where this might be bad. I'll let you know if that's the case, but so far I think it's pretty good that this happens as is. So at this point, you've got your checkpoint videos. You've trained. Again, it takes 12 hours, which if you're used to doing StyleGAN, that sounds really short. So it's a little bit of time, but not that long a time. So next we want to do is we're going to look at some inference stuff. So inference. In order to do this, we are going to just make sure we're in our fine-tuning folder, which we probably were already. This is just set up in case you want to skip over the training and come back to just inference. So for inference, what do we need to do? Just like with a text prompt within text to image, we need to feed a text prompt to our video. What I would generally recommend you do to start with is just go into that training folder when we did captions. So just grab one of your captions out of here, right? So we can just go in here and let's say we'll just grab one of these captions. Oops, Control C, hit X, and come down here. So this cell, I admit I could probably be a little bit cleaner, and maybe I'll clean it up in the future. But for now, let me just, actually this needs to get deleted as well. This is too much in here for everyone. Okay, so what do we do here? So a couple things. So first off is we've got a path to our model file. We'll come back to that in a second. We have our prompt, so I'm just going to paste in my prompt here just so we've got it. And then we've got a negative prompt as well, which I'll come back to in a second. So first off, I've added in my prompt. Next is I need to make sure I'm using the right model file. So this my trained model file should always point to your checkpoint folder, not to an individual model file inside of it, but just the folder. So in over here, let's come back over to here, and let's say we're going to use 15,000. So let's copy the path to that and put that in here. And now we've got a path to our files. So what I would recommend you do is as soon as you finish training, actually run one of these off, like run a couple samples with each checkpoint system. So start at 2,500, move up to 5,000, move up to 7,500, 10,000, etc., and play with a couple different prompts. So play with a prompt that came directly from your model file or from your training data from when you created the captions, but then also play with a couple that are sort of tweaked. Because I think what you'll find is that the lower values, kind of there's like this sweet spot of where it remembers enough of your video to look like your video, but it's also, you can introduce other ideas in the prompt and it will still sort of like remember those, and like from the previous generation will keep some of it. It's a little bit of an art here, I think, of like what model is working best for you. Play with them. You might find you really like one versus the other. Again, this is not a thing where like you want to rely on just one sample to tell you the whole story. So you might have to generate maybe 10 samples for each one of them and just sort of see what makes the most sense. Okay, so there is also a seed if you've done seeding in any text prompt system. You can set a variable or value here. So let's say you want to actually use seed 99. You just set in 99. I've got this set to auto randomize a seed value. This seed value will be stuck at the end of your video prompt, so you can also see what seed it used in case you like it, want to go back to it. And then you've got prompts. So we add in our prompt here. Again, this is just like any text to text prompting system. So you could add in, beautiful, colorful, all of the sort of text prompt hacks that you would go with are all welcome here. I don't know if like some of the hacky stuff like ArtStation works here. I would assume so because it is trained on like a version of Stable Diffusion, but I couldn't tell you exactly like how much different it is from other versions, so you might want to play with that a little bit more. I've also added in negative prompting here. The key for me is I really wanted to add in the Shutterstock to try to remove that text. So I've added watermark, text, Shutterstock. We'll come back to this in a second, what the plus means. Some other ideas, just a way to sort of reduce and hopefully remove that watermarking. So far, it does work pretty well for me. So this uses a tool called Compel, which is basically also allows you to do prompt weighting. So you'll see the plus here allows you to weight Shutterstock a little bit stronger. So this is actually a positive weighting, but on the negative prompt, which means it's going to really try to remove that Shutterstock text. I might even do something like this where it would try to remove anything that looks like a watermark. Similarly, you can also wrap them in parentheses, and that will be a weighting of the entire phrase. So this is blue background and weighting that heavily. You can also do negative prompting. That will reduce the amount of weight that has in your prompt. But this is just a nice little library to allow us to do that. Next step is we want to go in and actually figure out how many frames we're going to generate. So inside of this command here on line 31, this will generate 100 frames. You could set this to be lower. I have found that you can't set it to be much higher than like 120 or 150. Because of the way this tool works, it stores all of the frames in your GPU RAM. So if you set it too high, it will actually add a memory error. Which is a little annoying. I will eventually look at a way to fix that in case you want to do a really long video. But also, these tools don't particularly work well with long video anyway. So you can kind of figure out like this is about the right length. For those of you that are interested in stuff like guidance scale or the number of steps we're going to generate, you can also set that here. These are set to the defaults based on what the repository said to use. I've heard some people say that if you set this to a higher value, you can get with a lower step scale, which would mean a little bit faster. But as you probably know, setting a higher guidance scale can sometimes introduce artifacting. So I think 9 and 50 works pretty well, but your mileage may vary. You may be asking me what's the frame rate for these. You can actually set that. So on line 35, you'll see you've got 18. So that's going to set it to be 18 frames per second. If you want a 24 frame per second video, you can certainly set that here as well. So I'm going to just add a little bit more to my prompt here. Beautiful flowers. Let's say, I don't know, let's try trending on ArtStation. Let's see if it actually works. I have not tried this yet. Obviously, there's way more prompting you do here, but I've sort of kept this pretty simple. The other thing you might want to do is set your output path. So let's just set it to content. That way we generate it to the content folder and not to, I don't know, into my drive account. Because again, this could fill up your drive fairly quickly. At this point, you are ready to run this. So go ahead and hit run. It's actually the first time I really worked with diffusers library in code, and I actually found the Hugging Face diffusers library is fairly well documented. So I was able to find the stuff for compel, which is the weighting library, was fairly well documented. It was pretty easy to implement. So I definitely recommend that if you want to dig into this more, you can look at that stuff. I also know, I think Auto 1111 now has an extension for this. I don't think they do training there, so you would want to do training here and then pull in your model and do all that stuff through Auto 1111. I haven't really looked at that too much because I've been enjoying playing with my own tools for a little bit. But I think this could be, I assume there's stuff going on over there that is probably pretty cool and pretty powerful. I think I saw someone saying ControlNet set up to work with that too, which again is like probably mind-blowing. There's probably some really, really cool stuff you could do to maybe help with coherence if you're saving out the canny edges or whatever it is. It would probably make a lot more coherent use of that tool. This one again takes a little bit of time. While this is running, I'll also tell you there is a batch script down here. What this will allow you to do is it'll allow you to point at your actual training folder. So it'll point at your training captions. Sorry, I should say there's so many folders and training stuff in here. To your captions, so you would copy this path. And if you paste that path in here, what it will actually give you, this one, is it will run through your JSON file and pull out every caption and then generate a single video for every one of those captions. This is kind of a nice little like testing interface. So if you just want to see what your model looks like, you could run this. It does take a couple hours depending on how many captions you've generated. So just be aware of that. It would take a little bit of time, but you would then have a whole batch of videos. So you could run this overnight, look at it in the morning, and then say like, oh, checkpoint 2500, not enough of my new video. But checkpoint 10,000, too much. So somewhere in the 7,500, 5,000 range is the best part. So that script exists if you want to use it. It doesn't include some other funky things in here. Like what I'd probably say is you don't need any of this stuff. I was doing this thing where I was trying to play with changing the prompt colors. So I was trying to change the colors of the flowers to sort of see how this worked. It was sort of hit or miss, to be honest. But it'll pull your prompt in, and then you can also add a negative prompt. I don't think it's set up for compel yet, so if that's something we need to do for anyone, like let me know. We can play with that too. Yeah, I mean, in general, like this is pretty much it. You'll see now that we've got our Inference tool working here, it actually generated our video. Let's go ahead and see what our video looks like. We'll download this. And I should say, these videos actually show up correctly, so you can open them in QuickTime. You're welcome. So it looks kind of like my sample video, but it's very flickery. Coherence is not the strongest suit for these models. Any sample you look at, like especially like the Will Smith eating spaghetti, you'll see it still flickers a decent amount. It's got some coherence, but it's still like not perfect. And the different seeds will also have different coherency levels. There's different ways to prompt this. We're still in like week 2 of this tool, so I expect there to be a lot more options and a lot more like cool things to play with over the next couple months. Maybe again, everyone moves to Auto 1111, and my collab notebook is only here for training. I'd be fine with that. But I just want to give people an idea of this stuff because I think text video will be kind of cool this year, and like we'll see a lot more tools. And I'm always looking for stuff where I can train it on my own thing. As well as just sort of getting a little bit lower level than, say, a GUI tool, just to sort of understand it. So I hope you'll find value in this collab, even if you just like play with it for a day or two and sort of understand a little bit more about it. If you do find settings that work really well for you, please let me know. I've run, I don't know, maybe 5 trainings on this, so I really don't know all the settings. I don't even think the repo owners do either, so it's kind of worth like just experimenting and telling people what you think about it. Yeah, so with that, I have talked a lot about this tool. I hope you find it helpful. Again, thank you for backing me either on Patreon or YouTube. I really appreciate all of the funding that people give me because I can do more stuff like this, and I always want to return it back to the community. So thanks again. I hope this is a good reward for everybody. Let me know if you want more like this, more models. I'm happy to even maybe share the model that I trained on this thing. I can send that to people. Maybe that'll be a good thing to do too. Yeah, so I hope you found this helpful. Please let me know if there's other things I can do for you while you play with it. And with that, I will wrap it up for the day. So thank you so much.